All right, we're going to review how to write equations from situations. There's a couple different equations that we've learned in the past. So we've learned a y equals mx plus b sort of equation. This is our slope-intercept, where m is the slope and b is the intercept. Now, slope is another thing that we can think of as rate. So if someone's going a certain amount of speed or something's happening per something else, that's going to be your slope or your rate. And the intercept you can also think of as your starting point. So if there's any sort of like initial fee, or when they started the race they were already 50 yards ahead, anything like that, that would go for B. Now this is a really good equation to use if you have this information but you don't have any like sort of total that you're working with. Now we've also worked with the fact that if you don't have a starting point, then you just don't put anything. You don't need to say plus 0. You would just basically do a y equals mx equation, just put in what you have for that rate, and then that's it. The other equation that we've worked with is the standard form. So this one's where we kind of have two different things that were given to us, but we have our total. So this might be something like if there's two different costs for like adult tickets versus children's tickets, or there's like something like, oh, I have $17 to go to the store with and I need to buy bread and cupcakes, and bread is worth this much and cupcakes is worth this much. That's where you would put that information. So these are some sort of cost or value that goes along with X, and cost and value that goes along with Y. Now, and with all these equations, like we've been using X and Y, but like you can use pretty much whatever you want. On the Kahoot and on PowerSchool, I will be using X and Y, however. Now, standard form you can see is really, really good if you have a total. So if it's something like they traveled 75 miles or you have $200 to work with, that's a given total. So this would be a really good equation for that sort of case. So let's try the 4 warm-up problems that are on PowerSchool. So the first one says, Bob is filling his pool using a garden hose. It had 600 liters in it when he started, and the hose puts out 35 liters per minute. Write the equation that reflects the amount of water in the pool based on the amount of minutes that have passed. So let's just get down what we know. So we know that it started at 600 liters. And then that 35 liters per minute, because it's a per minute, that's going to be a rate. So here we have a starting point and a rate. So now we have to decide which equation we want to use. Well, because we don't have a total, we don't have an endpoint, we're going to want to use our slope-intercept form. So for our slope, for m, that's going to be whatever rate's happening. So that's the 35. And b is going to be our starting point. So that's the 600. And so the equation would just end up being y equals 35x plus 600. Because with x, it represents is the amount of minutes that have passed, and then y is how much is in the pool. So we could take any amount of minutes that have passed, 30, 75, 200, plug that in for x, and calculate how much water should be in the pool. The second problem says a local movie theater charges $9 for adult tickets, $6 for children tickets. Write an equation that would calculate the total cost based on the amount of adult and children tickets. So we know that an adult ticket is $9 and a child ticket is $6. So because we kind of have these two given values for these two different variables, that's going to tell you we have a standard form. Now this one, they don't actually tell us the total, but with this equation we could do that with any amount of total that we have. So our standard form, so for adult tickets that'll be X, it doesn't really matter Y. And then children's tickets will be Y. I mean, honestly, these could be switched, it won't matter. And then this is like how much money it would be. So if it did say something like, okay, you have, I don't know, $35 to spend, you could put that here, and then there's all sorts of combinations that would get you up to $35. There's probably only one that would get you exactly there, but anything under that you could buy with $35. All right, for 3, a cereal company uses 1 pound of oats for every 3 boxes of cereal they produce. Write an equation that represents how many boxes of cereal they can produce based on the pounds of oats they have. So we really only know one thing. They need to use 1 pound of oats for every 3 boxes of cereal. So because this is a per sort of statement, like 1 pound per every 3 boxes, this is a rate. So whenever we're given a rate, that's when you're going to want to use a slope-intercept form, since rate's the same as slope. In which case, that is going to go right in for M. So 1 pound for 3 boxes. And then you might be wondering, well, what do we do with B? There is no B. We don't have any starting point here. We're starting from 0, so we don't need to say plus 0. If they told us something like, oh, you're already in, like, I don't know, 5 pounds of oats, and we could put that here, but we don't have anything. So you would actually just leave it as the 1/3 x. And number 4, Jim wants to save up to buy a car. He started with $150 in his account, and he deposits $20 every 3 weeks, right? The equation that represents the total amount of money in his account based on the weeks that have passed. So let's start with what we know. He starts with $150, and then he's putting in 20 for every 3 weeks. So here again we have a rate and a starting point. So we're going to use our slope-intercept form for that, where B is going to be our 150 and our slope is going to be the same as our rate. So this is the part that's a little tricky. You can just leave it as 20 over 3. Because if we were to graph this out, you would just go up 20 over 3. That's easier to work with than changing that to a decimal or a fraction. And then B is our 150 that he's starting with. So there's the amount that he started with, the fact that he's putting away 20 per week. So we could put in any amount of weeks, 17 weeks, 2 weeks, 13 weeks, whatever, and calculate how much money he should have.